Hi, welcome to part 2 of the series on machine learning. So in the first part we built a chatbot, and in this part we're going to build some additional use cases. So let's get started. Let's first create a sentiment analysis pipeline. So we're currently in our virtual environment here. So if we say deactivate and then reactivate our virtual environment, we have to cd to our folder and then activate our virtual environment. So now in this environment we already have pip packages installed, so we can actually say pip freeze and pipe the result to requirements.txt. So we'll see that this has all the packages we need, including PyTorch and NumPy and Huggingface here. So let's take a look at our first sentiment analysis pipeline. So we can create a pipeline that looks like this one. So we'll call it sentiment analysis.py, and we first have to import torch, and from transformers we import pipeline. We pick a pipeline. In this case we pick sentiment analysis, and then we provide a string to classify that. So let's run this simple pipeline. So when we run it, it says label positive, score 0.99. So if we were to change this value to say that if we were to change it to say something different, we can run that, and we find that it gives us a different score. So in this case it's 0.997. We could also change it to say something less positive. So if we said there's a chance of nuclear war, and we ran that. It says the sentiment is negative and the score is still up 0.99, so it's 0.99 towards the negative side. And we could try to find something neutral. So we said there's a lot of issues humankind needs to solve, and we ran that. So this time it was positive with a score of 0.991. So that's our sentiment analysis pipeline. Now let's take a look at text generation pipeline. So we'll create a pipeline called text generation.py. So in text generation py we provide a sample text. So let's say the text is I'm the author, Lewis Carroll. The meaning of the word Jabberwocky is. So if we were to run that, we can So we get this output. So let's take a look at the output. It says here, I'm the author Lewis Carroll, and the meaning of the word Jabberwocky is, in which, in the sense of the word Jabberwocky, refers to a man who, like many others, tries to get out of his bed using his babble of words. Is that the word babble or double? To gain access to a doctor's office, a place that is usually taken to the point where it is not necessarily illegal, even if the word may be in question. The word Jabberwocky refers to a man who tried to escape from the hotel of the night. So anyway, it's a long paragraph. So let's take a look at the next pipeline. So the next one is called zero-shot classification, in which we provide a number of candidate labels. So let's take a look at zero-shot classification. So we say touch zero-shot classification.py. Now when I run, or let's take a look at what we need for this. So here we have a classifier. The name is zero-shot classification, and we gave it the input. We are the droids that we've been looking for all along. And here the candidate labels are science fiction, documentary, economics, politics, and social science. So now we can run this to see what the output is. So we ran a zero-shot classification. And in this case, we got a set of scores, a dictionary of scores, and the dictionary of scores is highest for the first label. So let's take a look at the scores. So for documentary, we got a score of 0.38. Let's increase the font here. So for documentary, we got a score of 0.38. For science fiction, we got a score of 0.35. For social science, 0.17. For politics, 0.048. And for economics, 0.044. So the highest seems to be documentary, which may not be perfect in this case. So let's try another statement. So here we'll say that it was the best of times, it was the worst of times. And in this case, we can still give the same options. We can also give an option called satire, just to give it some additional options. And let's run that. So in this case, we got the scores back. So the first score is for satire, which is 0.338. Second score is for documentary, which is 0.229. So it seems that it thinks this is satire. For science fiction, the score seems to be 0.106. So this may not be the most accurate, so this needs more fine-tuning and improvement of the model. So let's take a look at the next one. So if we were to improve the sentiment analysis pipeline, we could do something like this, where we select a certain model. So let's do this example. So we're going to create the file called sentiment analysis 2.py, and in this one we import torch, and we picked a model called the BERT model, and we gave it 2 sets of training data, and we print the tokenized sequence and also the decoded string. So let's run that. So in this case, this is the dictionary of input IDs, where 101 and 102 correspond to the start and the end of the sentence. The remaining IDs are for each token. So understanding how a token classifier works in transformers, that corresponds to those IDs. And this is the decoded tokens, and here we're getting the label, which is positive, and a score of 0.99 for our string, understanding how a tokenizer works in transformer. So that's an example of sentiment analysis with a pre-trained model. Now we can take a look at attention mask. So the attention mask refers to which tokens are prioritized for attention, and in this case all of them are 1. So if it was 0, then it would not prioritize that token for attention. Now we can take a look at fine-tuning steps for a model. So if we were to create a version of the same script and say sentiment analysis 3.py, and in this one we could give it a simple model. So this is a pre-trained model again, and we are giving it the training data of God is a concept by which we measure our pain, and the mind is the matrix. And in this case we're using PyTorch, so we have to import these imports. So in our imports we can have torch and also import this as functional model. So if we run this one, so in this case we got the scores, and the score for the first set is 0.993, and that corresponds to the first string, which is God is a concept by which we measure our pain, and this agrees with what PyTorch gave us, which is 0.993 here. So the pre-trained classifier gave us 0.9929 and PyTorch gave us 0.993. In the second, for the second string, the minus the matrix, we got a score of 0.996 from the classifier which was pre-trained, which is this one, and we got the score of 0.9969 from PyTorch. So it seems that there's a close correlation there. So that was sentiment analysis, and now we can take a look at fine-tuning. So for fine-tuning, we have to follow these steps. We have to prepare a data set, we have to load a pre-trained tokenizer, we have to build a PyTorch data set with encodings, we have to load the pre-trained model, we have to load the trainers and train the new model, and then run PyTorch training loop. So we'll look at that in a later video. Thanks for watching. See you in the next one.